Okay, so now we're dealing with what's called a two-sided hypothesis test. All right? All right, so first off, I want everybody to get their blue packet. Now, just quickly write p-value somewhere on your blue packet, a nice empty space on your, so you get to use this on your quizzes. P-value less than alpha means we reject the hoe, right? And that means we have convincing evidence for the hop. Now remember, that doesn't mean we write that. You know, we have to write fill in what is the hop. It's the proportion of blah 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 blah. Okay. Sorry, this whole. Okay. So it's tendency for the hop. So if p-value is greater than the alpha, then we fail to reject the hoe. Now remember, it's like court of law. We don't find anybody innocent, and we don't actually find for the ha. Okay? We just reject, or the hoe. We reject or fail to reject the hoe. All right? And in this case, we don't have convincing evidence. For the hop. All right, so with today's notes, we have a two-sided hypothesis test. Not going to be too far from what we've already done. It says, Mr. Tyson's class likes to flip the Hershey's Kisses. Of course, you eat them afterwards. OC, one of Mr. Tyson's students, suspected that one-third, very important here, one-third of all flips would land on the base with the point up. That's our hoe and hop. The rest of the students don't believe her claim. In their desire to pursue scientific truth at any cost, which means, of course, eating more kisses, they flipped 1,400 times. Of those 1,400 times, that's going to be our N, right? 511 landed on their base. Since the students weren't sure if the true proportion was higher or lower, they didn't know higher or lower. They didn't even have a prediction whether it would be higher or lower. They just didn't agree with one-third. Therefore, we have P equals one-third and P doesn't equal one-third. Hence the equal slash to it. We're not saying greater. We're not saying less than. We're just saying we don't agree. Okay? So, this is going to be almost the same thing that we've already done. There's only going to be one extra step in step 5. And it's not a big deal. It's common sense math. You'll be fine. Okay, so as always, P is going to be the true proportion of all flips of Hershey's Kisses that land on their base. So they actually already gave us P for us. We don't have to write that out. So that's part of step 1 right there. Or right here. Okay? Now, the other part of 1 is, what is our N? It's 1,400. That's how many kisses were flipped. Our P hat is going to be 511 out of 1,400, which actually equals 0.365. We're going to leave it at 3 numbers, 365. And our alpha, 0.05, because it was not given. And remember, if alpha is not given, we always go with 0.05. That's step 1. 2, oh, I forgot to point this out. This is a wonderful gift in this one. Look at this sentence right here. all the conditions for carrying out the test are met. That's a very important line. That means they're telling us up front, large numbers have already been tested, and it's random. So we're done here. So we just write here, conditions met. Check mark. It's already done for us. They told us. We don't have to check large conditions, large numbers. They've already told us that. 3 has already been done for us. We're just going to rewrite it real quick as a decimal. So the ho and the ha, p equals 0.33, and p does not equal 0.33. Look how fast this is going. Easy, breezy, beautiful, cover up. Number 4, we do our math. Simple calculation. Z equals our p hat value, which is 0.365, minus 0.33, our p, over the square root of p, 0.33, times 1 minus p, which is 0.67, divided by our number 1400. Which gives us a p-value, a z-score, of 2.79, rounded. It's actually 2785. We like to go to 2 spaces for our z-score, so we look at 2.79. Now here's the only new thing we're going to have. So here's where the new thing is going to kick in. On number 5, we draw our beautiful little normal, but this time we're actually going to put in 1, 2, 3, and negative 1, 2, 3. Come on now, where are we going? Because we said this is two-tailed. So where's 2.79 go? Just, right there, 2.79. Put it, shade it, boom. Yay. But since we don't know if it's less than or greater than, okay, there's a chance that could be also over here, negative 2.79. So we put a line here, we shade this way. There's where the 2 tails comes in. We're doing greater than the z-score and less than the other z-score, the matching z-score. Remember, the key thing is here, symmetrical. And that's going to come in key with what we're going to do next. So when we look up 2.79 on our chart in our blue book, we get 0.9974. But we don't want that, do we? We want 1 minus because we shaded to the right, and that gives us 0.0026. That's the area right here. Since it's symmetrical, that is also the area right there. So we have 0.0026 to the right and 0.0026 to the left. So my p-value is actually 0.0026 times 2. And it's 0.0052. Because we have 2 tails to contend with. And now we're ready for number 6, the last step, everybody's favorite, the dissertation. We have 0.0052, my p-value, and we have 0.05, which is my alpha. It's less than. Okay? So now we start our dissertation. Since my p-value and it never hurts, we haven't done this, but it never hurts to do this. You can 0.0052 just to be more detailed. You don't have to, but you can put is greater than, or you can actually just do the symbol, or less than, if I did it right. It is less than alpha, which is 0.05. We reject the ho. And remember, you can say null hypothesis, you can say ho. Okay? Why do we do that? Because we have convincing evidence. I forgot how to spell this. Convincing. That's too close. Evidence. that the proportion of all Hershey's Kisses landing on the base is not equal to 1/3. That's it. All right. So this one, 70% of all U.S. Court of Appeals cases were civil cases. A judge wondered if this was true in her state. She examined a random sample of 1,300 cases from her state in the previous year and found that 886 were civil. Is this convincing evidence that the proportion of civil cases in the state during the previous years differs from the national proportion? This time we're going to test at 0.10. So it's telling us 0.10, so we're going to use 0.10. Okay, so number one, P, it tells us P is equal to the proportion of civil cases in the state during the previous year differs from the national proportion. So, in the state, last year differs from the national proportion, and you can abbreviate from national proportion. Abbreviate whenever you can. Fine with that. So, what's my n? N equals 1,300. That's the number of cases they looked at, the sample. My p hat was the 886 out of 1,300. And that's 0.68. And then my alpha was given to us, 0.10. On to 2. Now, this one did not have that special little sentence. So we have to say random, question mark, given, check. Because it told us a random sample of 1,300 cases. So random was given. Remember, this is a lovely template that's very easy to follow. Now we're going to do our number times our p hat, and our number times 1 minus p hat. Remember, I paid 68 cents for my candy, I get 32 cents back in change. So that works out to be 884 here and 416 here. Well, both of those are greater than or equal to 10. Check. We're good to go. Step 3 is just state the ho and the ha. Very easy. Ho, ha. So P is equal to 0.7. It told us at the very beginning, 70% for civil cases. They're not sure if that's right. So we're going to test not equal to 0.70. Number 4, we just do our math. Z equals 0.68 minus 0.7. What do you notice right off the bat right there? It's been different than anything you've done so far. Anyone? So what kind of number are we going to get? Negative. That's right. The first time we've had a negative. So there's our 0.7 times 0.3, 1 minus 0.7, divided by 1,300. And yes, for the first time, we have a negative z-score, negative 1.57. which kind of leads me to the shortcut I was talking about in the last problem. So on number 5, we make our little, right there. And we go 0, 1, 2, 3, 1, 2, 3. See how much I measure? -1, -2, -3. Okay, so where's -1.57? I don't care, just, it's right about here. Mark, shade. That's about as exact as it needs to be. If I'm doing -1.57, then I'm also going to do positive 1.57 right here, because it's symmetrical. And since I have -1.57, I can just look up on my chart and just use the number I get from the chart, which is 0.0582. That's that one, and that's that one. So if I double that, I get 0.1164. Okay, so on to everybody's favorite part. I'm just going to write it down here below this. Number 6. We have 0.1164 as my p-value. My alpha is 0.10. My p-value is larger. It's greater than my alpha. So I just start my sentence. Since my p-value, which is 0.1164, is greater than alpha, which is 0.10, we fail to reject the hello. Okay? Why do we do that? Because we have convincing evidence I'm sorry, we don't have convincing evidence. Silly me. We don't have convincing evidence. We don't have convincing evidence that the proportion of similar cases is not equal to 70%. Okay, so here's the homework. And if you're watching this at home, you just have to write this down as I say it. I need this up on the board. So, number 10. You can look right at it. What's my ho and my ha? So ho, p equals 0.73, and my ha, p does not equal 0.73. That's my ho and ha for number 10. What's my p hat for number 10? 132 over 200. Okay? Which is 0.66. So there's my p hat. What's my n? Just said it. 200. And my alpha is given at 0.05. Number 11. What's my ho and my ha? My ho, p equals 0.75, is given to you right there. And my ha, p does not equal 0.75. What's my n for number 11? 558, very good. What is my p hat for number 11? 445, which is way too many bullying occurrences out of 558, which actually equals 0.8. I think it's like 0.797, so it's around 0.8. And what is my alpha? It is given 0.05. Okay, so you do the rest.